Kia ora, everyone. Thank you for joining us for the full room today, and quite a topic to cover. We've had this topic a few times before. Actually, one of our Microsoft partners might have already attended this talk. We do have a couple of updates, but today we are going to talk about the New Zealand Cloud Region launch, which is coming out on time this year. So we're happy to say that it's on time, on schedule, within budget. I don't know. Okay, so I just wanted to run through a bit of housekeeping. So if you were able to come in on time and get some of the pizza and drinks, we'd like to thank our sponsor, CCL, which is owned by Spark. They are the first named partner who will be helping our businesses in New Zealand launch into the New Zealand Cloud region once it becomes generally available. So thank you, CCL. Of course, just a bit of code of conduct. Treat each other the way you would like to be treated. We're here with our peers, so we encourage networking and just being generally a decent human being. A few questions on where are the facilities. So we are in a room called CIE. If you walked past reception, you'll see that they're in the centre, but we've got tea, water, coffee, because we've got 2 hours and we've got a lot to cover, so you might need a bit of hydration. And also the garbage bin is just where you had the pizza and drinks as well. So either take it with you or just put it in the bins. Please don't try to put it in my hand. We also have, if something ever goes off, behind reception, we have the emergency facilities, restrooms. I've been asked a few times already. Female restrooms are just behind the lift if you take the immediate right as you leave reception. And the male restrooms are a little bit further down, same again to the right. And exit, again, it's behind the lift. We just go down the stairs and we will meet out the front in front of the Softail or transport, or we can go home if you feel like it. But that's why we need to do a bit of a head count and assembly to make sure everyone's all right in the case of an emergency. But without further ado, we're going to run through what's to be expected coming for the new New Zealand Cloud region. And we have a playbook available for you as well. Now, we do have a lot to cover, so we do answer questions can be held towards the end. We'll try and make more time because we realise that might be more questions than we might have anticipated. And some of the topics that we're going to cover are the launch process and timelines, still on time, resiliency, connectivity, and how to move resources between regions. So we've just recently released the New Zealand Cloud Region Playbook, and this is what we'll be covering today, hopefully over the next 2 hours, and also, of course, covering any questions that you might have. So if you get a chance, please download it. It has more information and more links to some of the things that we're going to today.
I want to say hello, first of all. Hi, everybody. My name is John Downs. I am a software engineer here at Microsoft. I've been helping out with the New Zealand Cloud Region launch. But in day job, I'm actually in patterns and practices, which is the team that looks after the well-architected framework, cloud adoption framework, the Azure Architecture Center, which is where all our reference architectures are published, and also the Azure Reliability Hub. Hopefully some of those names will be familiar for you. So I'm one of the people who builds and manages that content. And as Chimène said, we've got a lot of stuff to cover today. We're going to be referring to lots of different kinds of materials and resources and stuff that Microsoft has available for you. But we also know that a burning question in everybody's mind is, when is New Zealand North actually launching, and how does that all work? So maybe we'll cover that first. And as you can probably guess, this whole process is a very, very complicated endeavor, right? It's been several years in the making. And we really wanted to just talk through where we're at now. So we are extremely close to being able to say that this region is available for everybody to use. In fact, we are currently working with a handful of people around New Zealand, of companies and customers and partners who are actually testing New Zealand North region. It started this week. I've tested out New Zealand North. I've deployed stuff into it. It actually works. I've tested the latency. It is very good. And so it's all progressing very, very well, I'm saying. Now, what will happen is at the end of, or close to the end of this year, so in December, we will launch the region into what's called general availability. Right now, as I said, it's not quite ready yet. It's very, very close. But what will happen in December is that a whole bunch of Azure services will become available. So those are what we call foundational services. Foundational services are those that have no dependencies on other Azure services. So this is more of just like our internal kind of way of managing how we roll out resources. But then in the subsequent 90 days after the region launches, we'll also continue to roll out mainstream services. So this is where the bulk of our services sit. Over time, then we'll also be releasing additional what we call strategic services. These are services that require some more kind of business case or demand for us to be able to justify deploying them into regions so they don't come to region. So this is just a partial list, just to kind of give you a sense of where these resources sit, but you can see a more comprehensive list there, and of course the flavor has that. Now, I will call out a couple of things that are just a little bit on the tricky side when it comes to some of this launch process. So those three buckets, foundational, mainstream, strategic, that's how we think about services and how we sequence them. There are actually a few kind of edge cases or things that are a little bit surprising if you're not aware of them. So, for example, some services have, but themselves might be in one category, but then they might have features in a different category. So Azure Storage is a good example. Azure Storage is a fundamental service that needs to be there in the region for everybody to use. But archive storage, which is a feature of Azure Storage, is not available immediately by default in all regions. And so that's something that we're actually collecting demand on at the moment. There are also some services where they might have different tiers or different that might sit in different categories as well. So for example, Logic Apps. Logic Apps Consumption is considered a mainstream service. Logic Apps Standard, which is a newer version of Logic Apps essentially, that's considered a strategic service. And then the one that's really important to be aware of is that virtual machines, obviously they're kind of one of the building blocks of Azure, right? Everything on virtual machines. Those actually have lots of different families. So we have different families of virtual machines. We give them all incomprehensible names like DS2 and M4 and all sorts of different really complicated names that apparently have a meaning, but I've never been able to figure it out. But basically those different categories, those different families can sit in different categories. So at launch, we will have foundational services available, which include a few of those categories. Mainstream, a lot of a bunch more. But then for some of the more specialized SKUs, so some of the more specialized families that might require the unusual hardware, for example, or a lot of capacity, we don't necessarily have those available immediately. And again, we'll be collecting demand for that. If one of the key takeaways from this is if you are planning on using New Zealand North very shortly after it's launched, then some of the things that you might be expecting might not be available. Right. That period, roughly December and February. Luckily, we're probably all going to be at the beach over most of that time anyway. But if you do happen to be working and happen to be trying to deploy things, just be aware that some of those mainstream services might still be coming in. We also pay very close attention to the demand for services that New Zealand-based customers are looking for. So we internally talk about this a lot. We have a lot of different signals we get from different places around, particular customers are looking for particular services or particular virtual machine SKUs or whatever. So we're doing our best to kind of deploy as much as we can as early as possible, but please bear with us as we get this whole thing off the ground. One particular example where we're working very hard to try and prioritize some of these services is around enterprise scale landing zones. So if you've used enterprise scale landing zones before, this is a very common approach in Azure now to kind of bootstrap your environment and get the production workloads. Many of the services that you need for an enterprise scale landing zone fit in the mainstream category. And some of those may not be necessarily available immediately on launch, right? We might be slightly further towards February. Having said that, we are working really, really hard to try and make sure that the services that we do depend on, so things like firewall, for example, that they're available as early as possible. And there's actually a bit more guidance on this in the playbook. If you do happen to need a service that isn't there immediately, then there's a few things we can suggest as kind of interim workarounds as well. The other thing is really, if you are doing anything, planning on doing anything with landing zones or generally just with New Zealand North workloads, please make sure you evaluate the services that you're delivering. Look at how they correspond to those 3 buckets. Certainly the foundational and mainstream, by the time February rolls around, if you've got anything that fits into the strategic bucket, please make sure you let your Microsoft friends know. So if you've got an account representative or partner contact or anybody at Microsoft who kind of that information, they will appreciate knowing that as soon as possible. It goes into our planning, it takes some time.
If you do need to use the region, specific services are available, say that there are strategic or some versions of virtual machines, there are workarounds that you can do in the meantime until those services become available. So the first one is obviously consider where you can deploy temporarily to another region, such as Australia East, and then redeploy to New Zealand North when it becomes available locally. So a good example of this is, say you need to use Azure Functions before it is available in regions. You can consider if you can deploy it to Australia East first, and then when it becomes available in New Zealand North, you would create a new function app and then deploy your code to it with the temporary resource in Australia East. And we can talk a little bit more about moving resources between regions a little bit later. Another option, secondly, is to use a different service or a different SKU of the service. Or you can look at temporarily using a partner service as if one exists and it's available. But of course, all of these options have trade-offs. And so there's more information on the playbook about these 2, as well as some examples about how you might handle specific scenarios.
Just to summarize where we've got to so far, because I know this is a really interesting topic that a lot of you want to know about, just exactly what's happening when. Just to summarize, we are getting very, very close, right? This isn't a matter of something theoretically happening in the future. This is just waiting on some kind of final things to occur so that we can actually launch this to everybody. Services will be deployed and launched in different stages. So though, again, foundational services first, then mainstream, strategic based on the and so please make sure that you are being careful about particularly services like AKS or virtual machine scale sets or those kinds of services that depend directly on virtual machines. Because in those cases, things like AKS itself is a foundational service. We're using virtual machines with that are strategic services, then you're going to be able to just be careful about how you kind of think about this whole picture and make sure that you understand what the services fit into which buckets. And really what we're saying is that that period of 90 days or so between when we launch in December and when all of the mainstream services are available, that's going to be a really great time to start deploying things, to maybe set up some of the foundational kind of components that you might need. And of course, as I said, we'll all be going off on summer holidays probably anyway. So it's a good time to let the teams back in Redmond kind of push out all those services as we're off on the beach. And then by the time you come back, hopefully we'll be able to actually deploy a lot of the workloads that you're looking to deploy.
So to cover that, let's jump into resiliency. Here is a map of the world. And it shows all of the Azure regions globally, and this includes both existing and new regions that are coming out. Now, obviously, there's a lot of them, but if we zoom into our part of the world, our main regions that New Zealand uses are obviously Australia East and Southeast. We also have Australia Central 1 and 2, but they're more specialised and we won't be covering those today. So if we zoom in even closer to our part of the world, we have the upcoming New Zealand North region. And one of the most important things to understand about the New Zealand North is that we are not building a data centre, we're actually building multiple data centres, 3 in fact. So together, really? Exciting. And together, along with some other components, these together collectively make up the New Zealand North region. And this distinction is really important because having customer workloads spread across physically separated facilities is one of the key elements to their resiliency strategy. Next.
So what that actually means, right? So we are building data centers in Auckland. We're just not building a data center, we're building multiple data centers. Firstly, we went through a significant amount of due diligence to select, firstly, Auckland as a location for housing the New Zealand North region, and then secondly, to choose the specific places within Auckland that we build facilities. And there are all kinds of things that we considered, right? This happened a few years ago as part of the overall planning process. There were all kinds of constraints and factors that went into it. So we look, for example, at seismic risk, which here in Auckland also includes volcanoes. We look at the risk of extreme weather events. We look at where the submarine cables that connect us to the rest of the world are located, and the redundancy that's available in those cables as well. And then, of course, as part of our sustainability commitments, we look at how the power situation is in different places as well. And so in here in Auckland, that's right. So here in New Zealand, we're actually very lucky. We've got a lot of really high quality green energy and an abundance of it. So we're actually in a really good place to meet our sustainability commitments here in New Zealand. But New Zealand does have some interesting geographic challenges, and there are certain rules that we have to think about when we're creating data center locations, like we can't put it right on the coast, for example. New Zealand has a lot of coast, so that limits the locations somewhat. And we also have to think about the proximity of these facilities to customers. So based on all of these factors and based on large team of engineers spending a lot of time looking at all these different factors, they selected Auckland, of course, as the location. And then they also chose the specific sites within Auckland that did these 3 different facilities, as well as the other facilities that kind of make up some of the foundational infrastructure for the region, which we'll talk about a little bit later on. Azure has the concept of availability zones. Hopefully that's not a new concept to everybody, but basically these are independent, isolated data centers, or sometimes sets of data centers. The key thing is they're designed to be independent from the other availability zones in the same region. Each availability zone has to have separate power and cooling and network, and they have to be far enough apart physically that if something like a flood or a storm was to hit, it would be unlikely to affect more than one at a time. They have to be close enough together that they can communicate with each other. When we chose the locations for our data centers, we needed to ensure that they could meet all of these requirements, and therefore that all these facilities can be in separate logical availability zones. So in New Zealand North, as well as for many other regions worldwide, availability zones are an incredibly important part of our resiliency story. And it's important to note that when you hear Microsoft people talking about our infrastructure, you typically hear us talking about availability zones, or we don't tend to talk about data centers specifically. The reason for this is that, again, in some situations, it gets a bit muddy because there can be more than one data center in an availability zone, and it's kind of for capacity reasons or otherwise. To simplify that, we just think about availability zones and regions. So now that we've talked about how we design this kind of infrastructure, we'll start thinking about how we can do that for the kinds of things that you're going to be doing on top of this.
So, as you're sure you're already aware, being talented technical individuals, any architectural decision has to be made in the context of business requirements. And so when it comes to resiliency and Azure infrastructure, how it can be best used, there are several particular requirements that are most important when we take this into consideration. We're going to talk about a few of these now. I'm starting with resiliency requirements for availability and disaster recovery.
So these terms can get sometimes a bit muddied, and there's a whole big discussion about kind of the theory behind these. But basically, availability is about how you handle day-to-day operations. So one of the metrics we often think about from an availability perspective is our uptime percentage. So that's usually measured as a percentage, 99.9% or something like that, how much of the time our system is operational. And then we might set that as what we call a service level objective, an SLO, which is a way of basically saying this is a requirement we're trying to meet. And so, for example, if we have a system that needs to be operational, and we say 99.9% of the time, we calculate that out and work out what that means in real terms. That means that we're essentially saying we are happy to wear the risk of having this solution potentially being offline for about 45 minutes in a month. And obviously the more nines that you put on, or the higher that number gets, the more reliable your system can be, the more usable it can be. But there are also trade-offs with that as well. Disaster recovery is less about how we handle day-to-day operations. It's more unexpected or unusual events. And so there's a couple of different metrics and a couple of different ways that we think about disaster recovery. One of them is recovery time objective, and the other one is recovery objective. So let's talk about those briefly now. Imagine that we're talking about a hypothetical afternoon in the day in the life of a soon-to-be very stressed system team. Every day at noon, their system takes a backup of their database and stores it somewhere safely offsite. And this could be a cloud-based system, it could be on-prem, it doesn't actually matter. Now, at 2 p.m., everything falls apart. Something happens, doesn't really matter what, but the system goes offline. Maybe something happened in the cloud, maybe one of the team members dropped the production database, maybe an application deployment failed at a very bad point. Whatever happens, the system is now unavailable. The team works on the problem for a few hours, and eventually they decide they're going to fail over another copy of their solution, which might be in a disaster recovery environment somewhere else. So by 6 p.m., failover is complete. Just can now go back to using the system again. So what this means is that in total, the system was offline for 4 hours, right? That was how long from when it went unavailable to when it was available again. From the point of view, it was unavailable. So we call that the recovery time. But because the backup was taken 2 hours before the system went offline, it's possible that we lost 2 hours worth of data, right? Between 12 p.m. when the backup was taken and 2 p.m. when the system stopped working, right? So at that point, there was no data being collected. And so we call that the recovery, essentially the amount of data that was lost. So when we're thinking about resiliency requirements, we specify these two numbers, right? We specify the recovery time objective, which is the maximum allowable time that we'd be able to tolerate being offline and we may do it faster. And we specify the recovery point objective, the RPO, maximum allowable amount of data loss. Again, understanding that these are exceptional events that don't happen often.
It's helpful to have a customer think through these kinds of scenarios and be able to provide requirements that make sense for their business. And with the way things work in the cloud, it can be helpful to think about this in terms of risk, risk mitigation, and risk tolerance. We can think about a whole lot of different risks that could potentially happen inside our business. And here are a few that we have listed. And it isn't a very comprehensive list at all, but it does cover some of the more common risks that we think about when running in the cloud.
Yeah, and then for each of these risks, and we've just selected a few of them to talk about here, we can think about how likely they realistically are. So for example, in a cloud environment, hardware issues happen all the time. Right, with the volume of stuff that's going on in a cloud environment is very, very high. The chance of any one thing going wrong is also very, very high. Things like hosts rebooting, it's failing. We move workloads between machines because we're patching them. We move workloads between racks because of health signals we're getting. TCP packets drop because of solar flares or something. So this kind of thing happens so often that we call these kinds of things transient failures or sometimes blips. And really the idea is the cloud fabric will recover from these situations automatically. Do anything to step in. But it is something that we recommend that every customer should mitigate by following some of our guidance around things like retrying requests and handling transient faults and that kind of thing, which hopefully you're already doing. This is actually built into a lot of our SDKs and a lot of the code that you'll see anyway. But basically this kind of stuff falls into the realm of high availability. So it's recovery from these kinds of disruptions is just part of day-to-day life in the cloud in any scale environment. The second kind of risk is that a data center has some sort of major issue. So for example, a power failure or a cooling issue, going wrong with the network, that kind of thing. These kinds of issues don't happen super frequently, but they do happen occasionally. And when they do, we often will think about them as disasters. We may or may not. And if that's the case, workloads that are running in those affected facilities might end up needing to be moved elsewhere. And if we think about a whole region outage, well, those are incredibly unlikely. All three availability zones have to go down at once for this to happen. And so now generally what we're talking about are things like major natural disasters that affect a very wide geographic area, or something like a very significant disruption to a power grid for an entire metropolitan area, or some other major event like that. Now, as we mentioned, we also go to great lengths to try and avoid selecting locations to put our regions and data centers and so forth that will be subject to these kinds of risks, but and which is why these kinds of events are so rare. But we do need to plan for them. Now, if you're using availability zones and if you're using some of the other practices that we talk about a lot, you will be far ahead of the resiliency guarantees that you can achieve in your own data centers or in your own facilities, colos, that kind of thing. All of this needs to be kind of incorporated into your risk mitigation plan. And ultimately, you need to decide which of these kinds of risks are worth mitigating, which ones the costs outweigh the benefits. And there are cases where it just doesn't make sense to mitigate risks. But in some cases, if you're working with banks or governments or some kinds of healthcare solutions, they might have what we call a mission critical solution. And in those kinds of scenarios, it actually is worth many other kinds of risks as well, even despite the higher costs and other trade-offs. We'll talk about mission critical workloads a little bit later on.
So another requirement that influences how customers design their decision is budget, money to play with. So that includes the cost of the Azure resources themselves, of course, but things like disaster recovery environments and networking charges should also be factored into the cost of operating the solution. And what we'll talk about in that shortly is the more complex a customer's requirements, the more complex the solution is, and more often the higher the budget needs to be. This requirement to consider is the application performance. And so when we're thinking about using regions and availability zones, latency is the key things that we need to think about. So if we look at an example of how a client makes a request to an application, which then talks to a storage tier like a database, as we can see here, it has to make many separate connections to the storage tier. It's a very simplistic view of how this works. But if we look into this further, looking at that connection means it can take a latency in each of those connections, and we call that being chatty. So in those individual bits of latency, these chatty applications can start to add up. But if we can consolidate these connections, you can reduce the overall request processing time significantly. But how significantly that processing time changes that depends on the latency between those components, and this in turn depends on the distance between them. So if we take this and look back to our global regions, and we'll zoom back into Auckland.
So yeah, each of the data centers in New Zealand North is able to communicate with each other within about 1.5 milliseconds, right? And that's a general rule that we put in for most availability zones, most of the regions. And so what that means is in our application that Chimes was just talking about, let's say we're sending 10 requests to a storage service and those have to cross an availability zone boundary. That means we'd be taking about 15 milliseconds of latency just waiting on the wire. And 15 milliseconds of latency really isn't a big deal for most workloads. Sometimes it is, often it isn't. If we needed to go across regions, which is a much longer geographic distance, then the latency increases. And in the case of going from New Zealand to Australia, it's around 28, 30 milliseconds, like that. And this isn't because of our fiber connections, right? This is just the speed of light. Like there's not much getting around physics here. And so what this means, though, is if you add up that amount of time going across the Tasman, that might add 300 milliseconds to our application processing time if we're going back and forward 10 times. It really does start to add up, right? It starts to become noticeable to users, especially. Even within Australia, connecting between regions can take 14 milliseconds to go from Sydney to Melbourne, right? Because Australia is pretty big. And again, this adds up if you've got a very chatty application.
When we evaluate a workload's performance needs, we need to understand whether it's particularly chatty. We can do performance tests on these sorts of things. For example, if some legacy applications have been designed to at least on or designed to run on-premise data centers. It might not be in a hyperscale distributed cloud environment. And so they are often chatty because they haven't been designed to be efficient with the more modern network communications you would find on a public cloud, such as Azure. So you may need to think about why this matters. And many applications aren't so optimized so that 1.5 milliseconds is noticeable. If it takes 200 milliseconds for the application to process a request, then we really need to think to ourselves, what difference would 1.5 milliseconds difference really make? So when you take into account all of these requirements, as architects and designers, we need to know about what is absolutely essential and which aren't really needed. And there are trade-offs with all of these decisions. If a customer needs a highly performance optimized system, then they can probably get it, but it's going to change the way that we design and will most likely affect the way the solution is budgeted, costed, but also its reliability and probably some other factors as well. But if we prioritize reliability above everything else, we might end up with a system that's more difficult to operate and costs more. So basically, every time we push down on one lever, it affects the others as well. So the question here really becomes, how do you choose the right settings or levels for each of these architectural considerations for any given solution? So you're already familiar with the Azure well-architected framework, and this talks a lot in detail about the trade-offs between all of these elements. So in here, our focus here is reliability. So John and I will talk about some of the reliability approaches that you can use in Azure, but we'll keep talking about these trade-offs as we go as well.
So let's talk about some of the options Azure gives us for designing resilient solutions in Azure. And for this, we're just going to consider a very, very simple, absurdly simple application, just an application of some sort that connects to storage of some sort. And for the purpose of this discussion, we don't need to worry too much about exactly which services these correspond to, right? We're just thinking of them as kind of logical blocks. So that might be virtual machines, they might be app service or AKS, they could be, the storage could be Azure SQL or whatever, it doesn't really matter. So when it comes time for customers to deploy their components to Azure, you have some decisions to make around resiliency. And those decisions that you make can have some very significant trade-offs and consequences. The simplest option, if you were to just go in the portal and start clicking around and follow all of the wizards without really reading anything, what you would probably get is some resources that are deployed to a single region and they don't have any reference to availability at all. This is very cheap, and it's also the simplest option because you don't really have to think about it. What will happen here is that Azure will deploy a single copy of your resources into one of the availability zones. Azure doesn't make any guarantees where within the region it places those resources. So it's possible that both of those resources, the storage and application, could both go into the same availability zone, or they could be split across availability. Even if they're put together, possibly we'll move them later because we have made no guarantees to you. We might rebalance things at some point. If they are split across availability zones, then that theoretically affects performance, right? Because the application and the storage might need to go across availability. When the availability zones are very close together, right, which they are, there is still a very little bit of latency that's being introduced. Right? We talked about that 1.5 milliseconds or what. Realistically, that doesn't really make much difference to most workloads. If you have a chatty application, as we were talking about, then you need to be aware of that and at least test whether that matters for your workload, or whether that actually is.
But behind the scenes, Azure does what it can to keep that resource resilient within the availability zone settings that it's deployed to. But the challenge is, if there is an outage, that you're subject to potentially having all of your workload to be impacted because there is no redundancy within those basic level settings. Also, because there's no guarantee about exactly where your resources are deployed, you might actually be at even higher risk of an outage if something goes wrong in either one of the availability zones that it's been deployed to. So in this example here, if either zone 1 or 2 is down, then you will lose a critical component of your solution, and so your whole solution might not work. And so for that reason, this approach has very low reliability, and we don't recommend it for most workloads, but for some demos or POCs, it's perfectly fine. And another option is to deploy a specific availability zone, and this is called a zonal deployment or a pin deployment. Pinned because you're pinning the resource to a specific availability zone of your choosing. Now, the main benefit to this approach is that for ultra low latency workloads, this can give a performance benefit. And this is because your application tier talks to your storage tier. And if given it's in the same place, it'll be quite quick. But if you don't take into account the cross-zone latency hit, your performance can be very good, even demanding for very chatty workloads. But by itself, this approach doesn't really improve your resiliency, because if zone 1 has an outage, then basically the whole solution is gone for that period of time. When you use a zonal approach, you typically would use multiple zones together, and you deploy copies of your resources into each zone. And then you deploy a load balancer to route traffic between the zones, and you would decide how you would like that to how you would like that to operate. For example, in an active or if in a passive way. So if we take this and look at an example request, this request first hits a load balancer, which then sends to the primary application replica, which in this case we've configured it to application zone 1. So if this application makes a request to the storage layer, which is in the same availability zone, when we configure this kind of architecture, we typically set up the storage to replicate between the zones. And such as we can do this by using a cluster. And we can decide whether this application is synchronous or asynchronous. So synchronous means that the storage gets updated across all 3 zones before it's completed. Now, this does add some latency because the replication needs to talk between zones in order to process this request. But for most applications, this isn't a problem because 1.9 milliseconds, as we've previously discussed, isn't really a big deal. So overall, this kind of approach gives you much more resilience than running in a single. Any outage of any zone means the surviving zones are ready to take over, so you'll have an up-to-date copy of your data. But of course, you do need to deploy and manage all of these resources. So from an operational perspective, this can require more management. So you would need to configure and manage the storage replication. You can also handle how you would distribute the traffic between the zones, and you would be responsible for failover if there is an outage. If you're using an active or a passive approach, you would be paying extra for resources that you might not be using. So it's often recommended to keep an eye on such activities to make sure that you're using just what you need, not what's sensible.
So in Azure, we also have another way of deploying resources into multiple availability zones. We call this zone redundant deployments. And in principle, this is very similar to what Chimène was saying, but the main difference is that Microsoft manages it all. So we replicate the resource configuration for you. We replicate the data if there is any availability zones. We distribute traffic between the replicas. And then if there is a zone outage, then we take responsibility for routing traffic to the surviving zones automatically and routing the faulty zone. From an operational point of view, this is much simpler to manage. And for many services, we actually use an active-active model. So what we're doing is you're actually being able to use all of the resources that are being deployed for using one and having the other sitting there. This does depend on specific Azure services that we're talking about, but many of them actually already provide multiple replicas of your resource. So for example, Azure Storage does this. If you deploy Azure Storage, no matter what you do, there's always going to be 3 copies of your data at minimum. And so when you turn on zone redundant storage, all we do is we spread those 3 copies around availability zones, essentially giving you higher reliability while still keeping the same. Now, you might pay a little bit of extra cost compared to a locally redundant or a zonal deployment because sometimes there are resources here. We don't charge you for interzone traffic, so that part of it is free. The network side of it is free. But even if you do have to pay extra, it's usually a lot less than paying full price for a whole second instance of a resource, because again, we can basically do some clever things like spreading replicas around. This approach, zone redundancy, gives you a really good balance of several of these different architectural trade-offs that we spoke about earlier. You can also extend it do cross-region backups of your storage tier. Now, typically cross-region backups are pretty cheap. They don't really add much to the cost of a deployment. And backups again are often done maybe hourly or daily or something like that. This approach gives you even higher reliability because now you've got a geographically separated copy of your data. So of course that copy might not always be up to date. If you're doing a daily backup, it could be up to a day out of date. And so you might lose some data if your primary region was completely lost. Realistically, again, this is pretty unlikely. In the event of a disaster, you would also need to recreate your infrastructure in another region. It's typically possible to do, especially if you've got good practices around automation, structure as code, those kinds of things. The main thing that's often hard to replace in these scenarios is the data. And in this case, you've mitigated that risk by having a copy in another region. So in this case, the RTO and RPO for your solution is a bit different depending on the kind of disaster we're talking about. For a zone failure, your RTO and RPO is zero, right? There is no downtime, there is no data loss if an availability zone. For a region failure, it's going to be higher. And that's generally okay for a lot of customers, a lot of workloads, because again, region failures are unlikely. And so risk mitigation kind of calculation is a bit different there. Just to summarize where we've got to so far, a zone redundant deployment with a cross-region backup can be a really good choice as a starting point to give you a good profile of trade-offs for many different kinds of work. It means your primary region is going to be highly resilient, multiple zones that are all able to take over from each other very quickly. And it's easy to operate because Microsoft manages that multi-zone deployment and replication process and failover for you. And you've also left yourself the option of moving to another region if you have to, because you've got that cross-region backup of your data. So if the unlikely event of a whole region failure did happen, then this would give you some escape hatch. So again, for this reason, we typically say this is a good starting point for most workloads, certainly for production workloads.
There's always an however. There are some businesses who run mission critical solutions, and whether they need to mitigate all possible risks, this includes having all of the availability zones going down at once in a single region in the worst case scenario. And to be clear, this is not a likely event, and we specifically design and plan availability zones to be very resilient within region. But of course, it is possible. And as we mentioned before, there can be natural disasters or widespread electrical or network outages. So to mitigate these situations, you can consider a multi-region architecture. So multi-region might make sense for other regions beyond resiliency too, such as if you have users spread across the world, or if you're an independent support vendor building a SaaS product. And there are many ways that you can configure a multi-region solution. See here on the screen is an active passive approach that uses multiple availability zones in each region and asynchronous replication between them. So asynchronous replication means that the data is updated regularly after it changes, but not immediately. So async replication is distinct from a backup because it means that there is a secondary copy of the data ready to be used on a replica within another region. So in a multi-region deployment, you are paying, of course, for the extra resources, and you have to deploy, configure, manage, and maintain them yourself, unless you happen to use services such as Cosmos DB, and that will handle the multi-region replication for you. So the biggest benefit of this multi-region solution means that you're able to mitigate the risk of a whole region outage taking your solution down. From a performance perspective, asynchronous replication, it doesn't require cross-region traffic. So in the hot parts, so performance is still quite good. But this does mean that you can potentially lose data in a disaster or failover scenario. Because data is replicated asynchronously in this case, which means if a disaster happens, there might be some data that hasn't quite been replicated as of yet. So the RPO won't be zero, and its value will depend on how frequently that replication happens. Then, of course, you can switch to a synchronous replication approach, and this reduces or even eliminates your data loss. But every change needs to be propagated across regions, and inter-region latency is often quite significant, as John has illustrated just earlier. So every change needs to be propagated across regions, but the This means that the performance of the workload could potentially suffer. And so when looking at these two deployment types, there is a trade-off between resiliency and performance. And customers often have to think through this trade-off and apply it to their business context. And this is where us as designers and architects all come into play.
So if we were to just summarize all those different approaches we spoke about today, here's a rough idea of the trade-offs of each. And you might quibble with some of the details here. There's a lot more detail in the Relocating. Also more options than we could go through here as well, right? There's ways you can combine these together in interesting ways. But hopefully this gives a rough idea of the options you've got and what they mean. Hopefully also you can appreciate that there are some physical limits here, like for example, the speed of light, which comes into play, that affects the decisions that we make and the trade-offs that we have to. These approaches all have pros and cons. They're all valid for different scenarios. There is no one-size-fits-all approach for anything like this. But having said that, a good default option for many workloads, as we said, is zone redundancy with cross-region backups. It gives a really good balance across these different trade-offs. So if you're starting in Azure and you have no idea where to start with resiliency, this is a pretty good place to begin. And then you could go up or down here, depending on what you.
So if we go back to the cloud-related risks that we spoke about earlier, this approach really helps to mitigate all of these risks. So if we click next. So if we take a look at the first risk that we covered earlier, the application tier should be following our standard recommendations for resiliency anyway, such as retrying transient failures. And everybody should be doing this no matter what else they're trying within the application. And then by using zone redundancy, they can mitigate the risk of data center region outage. This could probably do with no data loss and completely with automated failover. And this is actually pretty impressive as compared to what they can achieve with on-premise environments today. And of course, in the extremely unlikely event that there is a complete region outage, then this option can help them to recover. They'll have to run the recovery process manually, so their RTO and RPO won't be zero in this situation. But at least they'll still have their data available, which is probably impossible to replace otherwise. But their backup frequency will determine their RPO for these kinds of disaster. The customer has invested in good automation, such as infrastructure as code and automated deployments, and this will help them achieve a low RTO as well. But of course, these recommendations don't suit every situation, and this is just one option of many that you can consider. So obviously we need to make an informed decision about what to do for each scenario that we approach for the business context.
Historically, Azure's approach to resiliency has relied heavily on having paired regions, so pairs of regions that are paired together. We have availability zones, which, as we've talked about, provide a really good balance between performance and resiliency. And so we're actually encouraging everybody to use availability zones in the first instance. And because availability zones are such a key part of our resiliency story now and our strategy, you will have seen us start to move away from an emphasis on paired regions. Most of our newer regions, Zealand North, don't have a secondary paired region. Instead, what we're doing is encouraging customers to make use of availability zones, as well as some of those other approaches we spoke about to achieve their resiliency needs. But there are some cases, of course, where we do need to deploy things across multiple regions. And sometimes we get asked how does it work if there's no region. For the majority of Azure services, it works exactly the same way that you do it today. So for example, the Cosmos DB, Azure SQL, API management, to name three, all of them, if you go into the portal and use the geo redundancy settings, they show you a big map of the world and you can just click on regions that you want to replicate your data to. Zealand North will become available in that map. And so that will continue to work just the same way. The key service that most people are thinking about when they're considering paired regions is Azure Storage. And specifically geo-redundant storage, or GRS, which is a type of replication that goes between paired regions. It's true that this type of replication will not be available in New Zealand North because it does rely on paired regions. However, there are other approaches that you can use So for example, blob object replication is a feature that's been in Azure Storage for quite some time. This gives you a lot of flexibility actually in how your data is replicated between regions. And of course, you can also design this yourself if you need to. So if you've got an application that can write to storage accounts in multiple different regions, then you can kind of configure this however you want. You'll also see us publish much more guidance about this. We've got some already in the well-architected framework and the reliability hub, and there'll be more. One of the things you need to watch out for when you use a multi-zone architecture is the numbering of the zones. This is especially important when you're deploying zonal resources, in other words, pinning to a specific zone, because each Azure subscription has its own logical ordering of availability zones. So one subscription sees as availability zone 1, might be what a different subscription sees as availability zone 3. So internally in Azure, we have this concept of logical and physical availability. And that mapping is different for each subscription, and that mapping is set when the subscription is first created. So this is really important to know, especially if you're configuring a latency-sensitive workload, because maybe you want the application server and the database server to be physically close to each other. And so in that case, you want to make sure that you're putting them in the same availability zone. You need to make sure you do this mapping. And also, if you're thinking from a resiliency point of view, you need to make sure that you're spreading your resources across those zones and not accidentally putting them all in place. So again, you can map these together. There are various approaches you can use to do it. We've got some more details in the playbook.
We know we've just gone through a lot of material, and it is quite a lot to take in if you haven't attended our previous sessions before. But if you don't feel like you quite get everything, there is still the playbook available. But the big message that we'll hope you walk away with is that there are a lot of flexibility and options that you have to design a solution for resiliency and all of its other requirements for different businesses. But of course, each option having its trade-offs, it's important to have a good understanding of the different approaches, as well as your customers' business requirements and risk tolerance, and help them to guide them make the right choices. But whatever you do, availability zones are a key part of the resiliency strategy. And we recommend that most customers and businesses use multi-zone deployments because of most situations, it does provide a great balance between resiliency, performance, cost, and complexity. For those mission critical solutions, you can also look at deploying across multiple regions as well. So let's cover connectivity options for New Zealand North regions and about how traffic gets in and out of Azure. And we'll also include high availability, disaster recovery, and ExpressRoute availability.
So first, it's probably worth just quickly reviewing how traffic enters and exits the Microsoft network and how it reaches Azure. There are multiple ways in which users can, or on-premises systems or other things, can connect into Azure. Typically, the two main ones are public internet connectivity and some sort of private connection, usually through ExpressRoute. You can also think about VPNs, which are both point-to-site and site-to-site VPNs, and software-defined WANs and those kinds of things that can layer on top of this. Microsoft's wide area network, our WAN, provides connectivity across our global network of data centers and also our edge sites, which are those facilities where traffic can relay our network. The network is one of the biggest networks in the world. It consists of a massive amount of fiber that we've deployed across the planet, or that we've leased. And each Azure region contains two things called regional network gateways. So I mentioned before, there's some other stuff involved in the region beyond just the data centers. This is an example of one of those. These are the things that enable connectivity between all the data centers in the region, as well as bridging out to the global Microsoft network. Traffic enters or leaves the Microsoft network in an edge location. And so we have edge locations here in Auckland. We actually have two different kinds of edge locations. You might also hear them called POPs, points of presence. So public edge locations are those that are used for connectivity across the internet, and private peering locations are those that are used to support private connectivity through ExpressRoute. So many enterprise customers need a secure, high bandwidth, low latency, dedicated connection from either their office or maybe from an on-premises data center or co-location facility into Azure, and that's where ExpressRoute comes in. thing that's interesting to note about ExpressRoute, if you're not aware, you don't typically pay for egress traffic when you use ExpressRoute. So traffic that leaves Microsoft network, you don't get billed for that. So in actual fact, for some customer situations, even if they don't need any of the other benefits of ExpressRoute, that by itself can actually make it worthwhile. Just something to keep in mind. Customers can use ExpressRoute today with workloads that are already running in any of our other regions worldwide, so Australia. And actually, we have quite a few customers here in New Zealand who are using ExpressRoute circuits to connect to their resources. That's just a very quick kind of primer on how traffic enters and exits Azure. But now let's look at how ExpressRoute connectivity will work specifically when New Zealand North. Today, customers can use ExpressRoute to connect from their premises here in New Zealand to virtual networks in Azure that are in Australia or any other region. There's a couple of different ways they can do this. One is by using a partner common approach. So you can contact a partner like Spark, for example, and say, I want an ExpressRoute circuit. They then set that up for you. Or in some circumstances, you can use something called ExpressRoute Direct, which is also supported here in those ExpressRoute connections, regardless of type, go through the ExpressRoute point of presence. Here in Auckland, that's in the Vocus facility. When New Zealand North is launched, customers will also be able to create ExpressRoute circuits to connect to resources that are in New Zealand as well. Nothing about the network edge has changed at all in the process of setting up New Zealand North. What that means is that it will simply be able to route traffic to the newly added region when it's available. So if you've already got an ExpressRoute circuit in Australia, nothing changes unless you want it to, right? You don't have to do anything to when. If you have virtual networks in New Zealand North and you want to connect to them, then you'll set up a new ExpressRoute circuit and point that to you. Then you can either use that as in addition to your Australia circuit, or you.
Probably don't already know, ExpressRoute comes in 3 SKUs, which have different capabilities and different pricing tiers. So the first one that we have is the ExpressRoute Premium SKU, which is available now and allows customers to connect to resources in any Azure region. But if we look at ExpressRoute standards, this one enables customers to express from New Zealand to Azure resources within Australia or New Zealand, because New Zealand and Australia share a geopolitical region. Both ExpressRoute Premium standard SKUs are already available for New Zealand-based customers. But when the New Zealand North region becomes available in December, we will have ExpressRoute Locals. Now, this provides a low-cost option for our businesses here, and you would only need to connect to virtual networks in the New Zealand North region through ExpressRoute Local. So these local circuits will become available again when the New Zealand North region becomes generally available this December. While ExpressRoute is a highly available service and it's backed by a 99.95 uptime service level agreement, when it comes to high availability, of course, it's a shared responsibility. So if we click next, each ExpressRoute circuit includes 2 physical links for redundancy, and customers need to use both of these physical links, and they would need to test their configuration for the failover processes quite regularly. The customers must also ensure that their side of the connection doesn't have a single point of failure. So customer premises equipment must be evaluated by the customer to ensure that it supports both the customer's high availability requirements. And at the application tier, because workloads must be able to handle retries correctly, short intermittent outages of ExpressRoute connections are considered normal and expected within the service level agreement.
Just like any other.
Yes. Yep.
So that's kind of the high availability side of ExpressRoute, the day-to-day kind of operations. But we also sometimes talk about disaster recovery for ExpressRoute as well. If you've got a mission critical workload, hopefully that is backed up by having some very explicit, ideally business-driven requirements that might indicate that you need to mitigate, for example, the risk of the whole point of presence in New Zealand going down. So when we're thinking about these different options, They do tend to add complexity and cost because we're essentially having to do extra stuff to kind of mitigate some risks. So really, it's important to think through how much of a need is there for such a mitigation before you actually start. To put some context, many of our largest customers actually today rely on a single ExpressRoute circuit. They don't do some of the stuff we're going to talk about now, but there are options if you do need them. So in the event that a whole ExpressRoute circuit, or sorry, the edge site, the point of presence goes down, you've got a few options for both mitigation and for fallback. The mitigation, one option is to deploy a completely separate ExpressRoute circuit, different POP in a different region. So for example, here in New Zealand, you might have a primary connection to the focus POP in Albany, which then gets you to resources in Azure. You could also deploy a second one going through Australia if you wanted to. Or you can deploy something like a site-to-site VPN. This is a common fallback strategy. So in that case, traffic is going across the internet, but it's encrypted over a private tunnel. Or you can consider using something like a software-defined WAN with a partner network. Partner network virtual deployment. And that again might provide an internet-based connection path that gives you a secure tunnel. So some other options that you can consider depending on the kind of workload you've got, depending on the you've got. So for example, if you've got an application that you need to connect to via ExpressRoute, maybe another option is to deploy some hosts using something like Azure Virtual Desktop and connect into that in the event of disaster. And that's particularly useful if you've got low latency workloads where you want to make sure that the host and the thing it's connecting to are very close together. You can also think about point-to-site VPN rather than flat VPN. So this is something that users would need to directly connect to. This can be more cost-effective than a site-to-site VPN, but it does require more administration. Or option is always there to use public endpoints, right? To switch to using the internet and then focus on more like identity-based access control as opposed to network-based control. So all of these options are available. They all have different trade-offs. They all have different pros and cons. They all require different considerations. So we've got more details on these in the playbook, as well as links to more information. Now, the final topic we want to cover today, before we take your questions, is about relocating resources between cloud regions. We know that there are a lot of customers who are very excited about the idea of moving some of their Azure workloads into New Zealand North. So what we're going to do is just talk generally about how region moves work in Azure, because the same principles apply whether you're going to.
So why would a customer move resources between regions? So one, that's obvious, is data residency. So when customers have data residency commitments, they might need to migrate their workloads back to New Zealand, or they might need to migrate data to New Zealand so that they can deploy newer workloads that depend on that data. So data residency can be based on legal or regulatory requirements. And if this is the case, verify whether this is really necessary, because it's not always a strict requirement. Sometimes it's just a nice to have. And often people think data residency is a requirement when it's not. It can also be based on cultural sensitivity of certain data, such as data from health or iwi organizations that need to make an informed decision about whether the benefits are worth the cost when looking at having data hosted locally. So you need to be aware that there are some situations where data might leave the geography as selected by a customer, and we've got more detail in the playbook about that particular scenario. Second one is latency. So currently the closest regions to New Zealand are Australia, East and Southeast, as we previously discussed, and both are about 25 to 30 milliseconds round trip time. And this is, as John mentioned, a fact of geography and the speed of light. And by locating resources closer to users, you can reduce overall latency. But we do need to be careful in this space because generally you want your applications and data to be close together. And often that's more important than latency itself from a latency perspective than having it close to the user. So another way you can also reduce latency is by using multi-region deployments or by accelerating traffic to a single region, which we'll talk about a little later. And the third one is capacity management. Now, while Azure as a whole has a massive amount of capacity in each region does have its limits. And by spreading your resources around, you're less likely to hit upon those limits. And when there are capacity constraints within a specific regions, sometimes customers who are a resident in that region do get prioritized. So it can be helpful to be located in the region where your business is based in. So how this works depends a lot on the specific products the customer is using. And we'll talk briefly about Microsoft 365, and then we'll talk about how things work in Azure. So for Microsoft 365, customers can purchase an add-on. And then when the region reaches general availability this December, the customer can then initiate a region migration process. So the good thing about this particular product, Microsoft 365, is that Microsoft will manage the migration for you and provide updates for the customer.
This is quite a different story to Azure. Microsoft 365 is a SaaS product that we manage on behalf of customers. We have a lot of ability to control how stuff works. Azure is a lot different, right? It's a collection of different products and resource types. Each of them is also a bit different to each other. And so there is no single process here. But the CAF, the Cloud Adoption Framework, does have some good guidance on relocating resources. The big thing for me to take away is that the CAF treats relocation, and it should have its own project team, its own timelines, its own budget, its own scope. And this should give you some idea that this isn't just a push button thing that you can initiate, right? This is a big amount of work. You need to typically initiate the relocation project. You need to create an overall strategy, which could be informed by the kinds of things that Chimène was just talking about. And then assessing workload by workload, you can look at them and decide which components to relocate, which ones to migrate, to recreate, and then eventually deal with the actual cutover. So let's talk about some of these points in a little bit more detail. First thing is, it's important to decide on the scope of a relocation project, and this might be different depending on the goals you're trying to meet. In some scenarios, you might only need to relocate a single resource, like a database, for example, or a storage account. This isn't very common. More often, you'll be working at the level of a workload. So that might be a set of different resources that correspond to one logical thing, or potentially multiple workloads. And in some cases, you might even want to move your entire Azure estate, right? Everything in Azure. You have some customers. You need to think very carefully about the sequencing going through this kind of exercise too, because during the migration process, if you're doing it bit by bit, then you might temporarily have some resources in different regions, which means you're now going across regions temporarily. So if you're doing that, you might incur bandwidth charges, you might add latency, and sometimes just by migrating things in a different order or thinking about that plan ahead of time, you can reduce some of those.
Many Azure customers use a landing zone, and we know that partners provide a lot of support to help customers design and implement these landing zones. So when customers do decide to move or extend their estate to a new region, this can affect how their landing zone is designed. So when you think of a landing zone, some resources are deployed non-regionally, which means that they can work across all regions, and you don't need to recreate or move them. Right. But in general, you won't need to make any major changes to policies, role definitions, management groups, and so forth. But some resources are tied to specific regions, and whether you decide to expand an existing landing zone to a new region or plan to move your entire estate to a different region, you'll need to establish the region-bound landing zone resources. So for example, if we take virtual networks, typically you would need one in each region to work in, and then you would establish a global VNet peering to connect the regions together. And this requires planning out of your IP address routing and so forth. Another example is log analytics, and there are different approaches that you might consider depending on how you use logging. So often you'll create a workspace in each region that you use, but you might need to centralize them. Another example is ExpressRoute gateways. So you need to deploy a gateway in each region that you will have ExpressRoute circuits that terminate in. There is a lot more in-depth information about how these works, and you can see it in the Cloud Adoption Framework documentation about how landing zones use regions and how to move or extend a landing zone across regions. So when it comes to other resources, there isn't a single approach to relocations that works universally. So some resources do support cross-region moves, and there are automated tools that can help with relocating these resources, although typically they will require some downtime. So we do treat it as a project, and many resources need to be recreated and redeployed in this time. So if you've built automation assets such as infrastructure as code, you'll have a much easier time than if you were manually deploying and configuring resources yourselves. So, for example, most stateful resources such as storage accounts or databases or some sort of data migration need some sort of data migration, and each service supports different approaches for migration. While Microsoft isn't typically able to actively perform region relocations for you, we do have guidance that can help, and you can see the playbook for the Azure North region or more information on how to go about that.
It's worth remembering when you're starting down this process as well, that a cross-region migration isn't the only option that you consider. So if, for example, your goal is just to support users or customers who are in a different region, then you might actually want to consider a different approach as well. One of them is a multi-region solution. So if you've got customers or users who are spread across the world, a multi-region solution can actually provide a lot of benefit beyond just resiliency that we spoke about earlier. It can be complex to design, but we have a couple of design patterns that can really help. So we've got one called deployment stamps, another one called geodes. Both of these are really useful for multi-region solutions. And when you create a multi-region solution, you've got really a choice about whether you effectively create multiple independent instances of your solution that are in isolation in different regions, or if you have them all kind of part of one system that can then fit each other's traffic. And then another alternative is to think about global routing. So this is really useful if you do need to stick with a single region solution. But what you can do is essentially speed up all of the traffic that's going to that region. So by using services like, for example, Azure Front Door, you can accelerate customer traffic so that even if they're coming from another part of the world, they can at least get to your single region deployment a lot faster. And they do that by essentially bypassing the internet. Approach works really, really well, again, when you have users who are spread across the planet. These kinds of workarounds, these alternative approaches, don't help if you've got strict data residency requirements you're trying to meet or something like that. But again, these relocation projects are pretty significant, so it is worth exploring your options before you go down that path. If you do decide to relocate, then we've got a few tips for you.
So one tip is whether you're recreating or redeploying resources, it's perfect time to make some improvements. So for example, some improvements could be, can you resolve any technical debt that you've accumulated, such as having scripts that are not in synchronization with your production environments, or thinking about whether you can increase your automation. Another one is ensuring that you're using availability zones and other resiliency strategies that you may not have had access to before. Or if you're building out test environments, can they be a part of your disaster recovery plan as well? And also, can you improve monitoring for your solutions of production?
The other thing to think about is that region moves have side effects, and sometimes those side effects can be pretty significant. These kind of make sense when you think about them, but they're not always obvious up front. So, for example, resource names typically need to change because they need to be unique. In the process, that means resource IDs change. So that means things like scripts might need to change if you've got S names change for many resource types because often they're based on the resource name, or they could be based on the resource name and the region. Most of Azure's public IP addresses are bound to specific regions. And so when you move a resource, the public IP addresses also change. And if you're thinking about private IP addresses, those are assigned by virtual networks. And so if you're moving a resource into a different region, it'll be in a different virtual network. It's likely to get a new private IP address unless you really carefully plan that. For similar reasons, private endpoints that are associated with Azure Private Link also get different IP addresses and different resource IDs. Now, in some cases, these things might change. In other cases, they might not. But you do need to think about all the downstream effects of what this might mean for things like, for example, firewall rules or automation scripts or those kinds of things.
So another consideration is to ensure that your customer has an Azure support contract in place before migrating resources between regions. And your team and maybe some of the businesses that you look after need to know how to open support cases and what those expectations are for each level of support For example, severity A cases require your team to be available by phone 24/7. And for some customers, that might not be.
Right.
Yes, they might not want to do that.
Also, if you're using Azure reservations for cost minimization, cost optimization, then those are actually bound to a particular region. So just be aware of that, but you can move them between regions. It's fairly easy to do. One of those things that just needs to go on the list of things that you make sure you don't forget.
So as we know that Azure is a global platform, you can and should compose our services together. And it's increasingly common to use services in multiple regions to get the benefits of the scale, capacity, latency, and service availability that a public provide.
Just to really try and drive this point home, right? Region moves are complex. They have to be treated as a project. They're definitely not trivial. They take time and effort and cost. So you really need to think carefully about whether this is the thing that you actually want.
As always, planning carefully. If you do decide it's the right thing to do, it does require very careful planning. And as always, please take a look at the Cloud Adoption Framework for more detailed guidance on how to locate resources between regions.
So hopefully that helps to kind of demystify this whole process. We know that sometimes there's a perception that moving resources is just a button that you can click. There is actually a button in the portal for moving resources. It hardly ever works. So just be aware that you can't rely on that. The relocation guidance actually spells out the resources for which that works. It's very small, but occasionally it does. And really, you need to look at all of the Azure services for your particular workload or whatever it is you're moving to make sure you fully understand what the impact is going to be. To finish up today, so once again, the playbook is a 25-30 page document that kind of talks through everything we've just gone through, gives lots of links, lots of other information, more specific guidance. It was written a few months ago, so some of the timeline stuff in there is probably no longer relevant, but it still might be interesting just to look at and see how we've come. And of course, coming very soon, you'll be able to try this all out yourself. The other thing to bear in mind is that we have all of these resources. We've talked about the well-architected framework, the cloud adoption framework throughout this Reliability Hub. Really great time when you're doing things like adopting a new region and like New Zealand North being launched. It's a really great time to review kind of your overall posture, to uplift anything that you think might need. So resources like the well-architected framework are a really useful way for us to be able to communicate what we think is important in terms of how you design a solution on top of Azure. New Zealand North is coming very, very soon. You'll be able to try it out yourselves in a matter of weeks. The playbook really does cover everything we could think of that will help you to plan for New Zealand North. By and large, New Zealand North is going to be just like any other Azure region, but as we've spoken about, because it is a new region, there's a few things to be aware of. If you've got more questions, we're going to be very happy to take some questions shortly. You can also obviously speak to any of your Microsoft contacts, your Microsoft account team or partners and so forth as well. So with that, I think...
Open it up for Q&A.
Yeah.
Check online.
Okay, yep, sounds good. Anybody have any questions they want to throw at us?
How do costs compare with Australia?
Yeah, so basically the pricing information should be going live, I think, at general availability. By and large, we're looking at, it's in the same ballpark as Australia East overall, or the Australia regions. I think in some cases there might be about a 5 to 10% increase, but that's still, I think they're still kind of working through stuff. That should all be announced pretty soon as well.
If an Z goes down, availability zone goes down, will the application see any latency issue? Contacts the data with the Z2?
It really depends on how you've designed the solution. So if you've got an application that's spread across multiple availability zones anyway, it probably isn't going to be a big difference to what you would have seen when the availability zone was up or not. If however you're doing like a failover between availability zones, then potentially. So it really does depend on specifics there. Again, the latency between availability zones is so small that in most circumstances, that's usually not an issue. Even if failing over between regions is usually a much more significant impact than failing over between events.
The RTOs and RPOs from other fully deployed.
So you're asking how our RTOs and RPOs? Yeah. So we have exactly the same internal kind of guidelines that we're following for every region. And so when you see, for example, we don't, for most of our services, we don't publish specific RTOs and RPOs anyway. We publish SLAs that are kind of uptime based. Those are exactly the same for New Zealand North. Very occasionally, you'll see differences in things like services will give you a higher uptime guarantee if you use availability zones. We'll apply New Zealand North. There are a handful of services where if you deploy across multiple regions, you get an even higher resiliency SLA. Those will depend on the service as to whether that's applicable here or not. But by and large, it's basically the same.
Of links in the chat there. Maybe post it to the meetup, or is there a way to access them?
All those links are still in the playbook. So he's just reposting it as we talk. We have our lovely VP Luke Murray online, who's very pragmatic about that.
Thank you, Luke.
Thanks, Luke.
Well done.
Yeah.
Office 365, you mentioned there was a add-on transfer, but what if we sort of wait see and maybe February, March, you might think of bring everything over.
Yeah.
Is there any particular need to have a add-on specifically, or whether automatically, or like when we move from Singapore to Australia, some people move straight away and some people kind of just hang around and then automatically it will ship it over anyway.
So that's a bit of a different scenario for that particular move. Or so the way that M365 data residency works is basically if you just set up a tenant for New Zealand, then you're considered to be part of the New Zealand geopolitical within this region of the world. And what that means is that we could store your data, your workload anywhere within that. So by default, that's just how it works. If you say I'm a customer in New Zealand, somewhere in that area. If you were to opt into the advanced data residency, what happens is we then say, okay, within Oceania, you can now select exactly which country you want to be in. New Zealand will be in that list. And so then we'll basically guarantee that we will keep it in New Zealand. So you're paying us extra essentially because we need to make sure that we can't rebalance that across everywhere. We've got fewer options that we can kind of relocate it. So that's basically how it works. Yeah. So you don't have to use that advanced data residency add-on, but if you want the data to be guaranteed to be in New Zealand, then that's the way that you do it. And as far as timelines for how long it takes to migrate, I think it's 90 days or so after the. Don't quote me on that. There is a link in the playbook too.
So those guys who've got early access, do they have access to the whole Azure resource list, or is it like a small subset?
They'll have access to the same resources, the resources that are available.
Okay.
Right now. The foundational and some mainstream are deployed. A lot of them, and yeah, there's quite a significant number of over the next.
In December, will things like backups and like log analytics be available?
Off the top of my head, I'd have to go back and check the list. Both of those are considered to be mainstream services, so I can't remember exactly where they sit in the sequence. I'm pretty sure log analytics is, if it's not there on day one, it'll be very soon after.
Yeah, cool.
Backup, I'm not 100% sure about.
Are the 3 suburbs the data centers are located in?
That's right.
The 3 suburbs where the 3 data centers are located?
So we don't disclose that. However, if you were to read the Heralds, then there might be a question that turns off on the page now and then, but we couldn't possibly comment.
All of those data centers are year 3 or 3, 4.
I'm sorry, say that again.
Are all those data centers are tier 3 or tier 4?
I don't know what tier 3, tier 4 is.
The standard of the data center deployment, like network power failure and
I see, right, okay. Yeah, so I don't know exactly how it matches up to those, but I know that our requirements for data centers is extremely stringent. We have some documentation on our, I think it's on the Service Trust portal about how we do, like how we plan for that. One of the things that we, for New Zealand specifically, when we were starting the process of designing the New Zealand North region, we looked to see what the data center landscape was like. Weren't satisfied with any of the existing players, and we created our own. So we wouldn't accept any of the current standard data centers that were already available. Create our own to be satisfied with them. So in terms of exactly what that maps to in terms of the tier 3 and tier 4, I don't know off the top of my head, but that information will be on the center website. Another region. In New Zealand, there are no plans for other regions in New Zealand.
Questions online.
You've done a great job.
Or we've confused you all.
Just keep telling everyone to read the book, right?
Yeah, pretty much.
All else fails, read the book.
Yeah.
Read the instructions.
My Teams is frozen, but if I was,
That never happens.
what was that service you're after? Log Analytics.
Log Analytics is, that's mainstream.
Mainstream. Yeah.
Yeah, but that isn't in order of deployment.
It's
Yeah, so yeah, I'm pretty sure Log Analytics is early up. It may, I haven't even checked, but it could be. I go back to my.
Will Fabric be made?
Fabric is not an Azure service exactly, so it's
Yeah,
kind of got a
right.
slightly different way of deploying. Bits of Fabric considered to be strategic, and so some part of them later. Having said that, we know that there is a lot of demand for the Fabric services, so we are hard to get them, but we don't have any commitment.
No further questions. We'll just hang around until 2 p.m. if you want to talk to us one-on-one, but thank you so much for your time.